This video is intended to assist you to do some applications of rational equations. You'll be required to set them up as an equation and then solve them. So the first type that you would see would be proportions, where you have a part compared to a whole. So in this example here, it's talking about an inspector examining light bulbs, and he has a sample of 200 and found that 18 out of that 200 are defective. So you can write that as a ratio, 18 out of 200. And then it says, at this ratio, how many defective bulbs can the inspector expect in a shipment of 22,000? So it should be proportional in nature. If 18 out of 200 are defective, how many would be defective out of 22,000? So proportional means that the ratios are the same. So you could solve this by finding the LCD and multiplying by the LCD, but this is the type of problem that you could actually cross multiply for. So you could do 18 times 22,000 and set that equal to 200 times x. When you multiply these two numbers and divide by 200, the 200s cancel out, so you solve this, put this into your calculator, and you get a value that x equals 1,980. So that means if you had 22,000 light bulbs, you would expect that 1,980 of those would be defective. Example 2 is similar because it's a proportion problem, and it says that a landscaper plants grass seed at a rate of 7 pounds for every 1,000 square feet. So that's a ratio of 7 pounds per 1,000 square feet. If the landscaper has 25 pounds of grass seed, how many additional pounds will he need to purchase for a job to plant grass on a 45,000 square foot yard? Which means we want those to be proportional. So 7 pounds will cover 1,000. How many pounds would you need to cover 45,000? So you can solve that for x. Again, cross multiplying 45,000 times 7 equals 1,000 times x. Dividing both sides by 1,000 gives you the value for the x. So 45,000 times 7 is 315,000. Divided by 1,000 is 315. But it says he already has 25 pounds. So it says how many additional pounds would he need. So in this case, you would have to subtract the 25 that he already has, because he doesn't need to buy a full 315 if he already has 25. So he would need 290 additional pounds of grass seed. The other type of proportion kind of problem you might see would be related to triangles. So a few definitions. Similar triangles have the same shape and different size. all the angles in similar triangles will be equal, and the corresponding sides are proportional in length. So what that means is if you had triangles that looked like this, and we know they are similar, and you can see that they're similar just by the layman's term similar. They look the same, as one's bigger than the other. But with proportional sides means the sides that correspond to one another, this slanted side and this slanted side, if you make a ratio with those and then a ratio with two other sides, they are proportional. So you could say that n over 2.5, this side divided by this side, is proportional to this side divided by this side. And they have to be the corresponding sides. And if this is n of the large triangle, then the large triangle needs to be on the numerator for the second ratio as well. You can't put 4.6 over 16.1. And once again, we have a proportion where in this case we can simply cross multiply. So 4.6n equals 16.1 times 2.5. Divide both sides by 4.6. So we get n equals, put this into your calculator, you get 8.75. That type of problem can be extended to more of a story rather than triangles, where we have a tree and its shadow, and it's hard to see, but there's a little person here and a shadow. So if you were to imagine the tree and its shadow forming a triangle, the person and its shadow form a very small similar triangle. So we're going to use the information we know about the height of the man and the height of the man's shadow and compare that to the tree and the shadow so that we can determine the height of the tree. So the forest ranger wants to determine the height of the tree, so she's going to measure the shadow. So if you imagine this is a triangle, shadow, tree, and then a similar shadow, man or woman. So you can set up the proportions. Man height divided by tree height equals shadow length divided by shadow length. So if you know, we don't know the height of the tree, but we know the length of the shadow of the tree. You can't see this probably in the video, but it gives that to you. 84 feet is the length of the shadow. It's also written here, 84 feet long. And the shadow of the person, actually it's a female, the female shadow is 7.5 feet, and she is 5.5 feet tall. So I have 3 out of the 4 triangle pieces, so I can set up a ratio. I can say the height of the person as a ratio to the height of the tree will be the same as the length of the shadow of the person relative to the length of the shadow of the tree. Cross multiplying 5.5 times 84 gives you 462, which equals 7.5x. Divide both sides by 7.5 and you get x equals 61.6 feet, which would be the height of the tree. And one additional type of problem is going to be where they give you information about circuits and resistances, and it's kind of sounds like a physics type of problem, but you don't need to know anything about what the resistors in parallel mean or what the circuits or anything about it. You just have to be able to get the formula and plug in values to solve. So it gives you this formula, kind of like we talked about the trajectory of rockets. They give you a formula, you just have to interpret the meaning of it. So it says the total resistance of a circuit that has two resistors in it in parallel. Doesn't matter if you don't understand what that means, but the total resistance is given by this formula. So the total resistance R uses this formula, and it tells us R1 and R2 are the two individual pieces. If the total resistance is 10, so that they're telling us that this R value is 10, so you can replace that with a 10. Now it's going to give us some relative information. It says one resistor, let's say this resistor, is twice the resistance of the other. So what we can say is R1 is twice R2. So we don't know R2, but we can say, well, we'll make it a variable. So if R2 is x, then R1 is 2 times x. So going back to this formula, we can plug 1 over R1, which we just decided was 2x, plus 1 over R2, and I'm letting x equal R2. So I have this equation with x's in here now. So what we did, I'll recap, we let x equal the resistance of R1, which means 2x is the resistance of R2 because it said R2 is twice the resistance of R1. To solve this, we can't do any cross multiplying because it's not a proportion. So now we have to use the concept of multiplying everything by the LCD, or inserting the LCD in all the numerators. So 10 factors to 5 times 2, and these two denominators can't really be factored. So identify the LCD, which is 5, 2 from this one, go and to the next denominator and identify any unique factors. In this case, 2 is not unique, but x is. Then go to the next denominator. X is already included in my LCD, so it is not unique. So 5 times 2 times x is my LCD. So I will insert that in all numerators. So 5 times 2 times x over 10 equals 5 times 2 times x over 2x plus 5 times 2 times x over x. And these are all times 1, but I left the times 1 out of all those because times 1 doesn't change anything. 5 times 2 is 10, so those cancel out. 2x cancels out, x cancels out. So I'm left with x over 1 equals 5 plus 10. So x equals 15. I let that equal the resistance R1. So resistance R1 is 15. Resistance 2 is twice that, or 2 times that. So resistance 2 equals 2 times 15, which equals 30. Because it says find the resistance of each circuit, so I had to find both circuits. We can check this by plugging these in. 1 over 10 equals 1 over 2 times 15. No. 1 over 15 plus 1 over 30. Replacing R1, which is 15, into here, R2, which is 30, into here. So 1 over 10 equals 1 over 15 plus 1 over 30. Put these two fractions in your calculator, add them together. They should equal 1 over 10.